Hello and welcome to the first of a few webinars from MISO, where we're going to talk to you about how to get the most out of FME. Okay, so the first webinar today will be on address matching utilizing the LLPG. Okay. So, welcome again. I'm Mike Robbins, software engineer here at datasets and MISO. So first, the business problem. Let's say you have your LLPG. It's a single source of truth for your business and your council. And sometimes not all the data sets that you have that you'll be working with are synced to this one source. Sometimes there'll be variance in that data, either people just using their own and it becoming out of date with all the other sources, or they might be using different core sources, such as a live gazetteer or census data, and the differences between those two. This can lead to a few issues with the organisation, either giving inaccurate or not up-to-date data to your customers, which means it will cost to fix that data either through custom software or just manual entry. Okay? So what you need is a fast, effective, robust way to fix that data or at least keep everything up to date. Okay? And that's where FME will come in. You need an FME workspace that can either sit on desktop or sit on FME server, so you can run it whenever you want on your desktop or get your customers to use it a bit of self-service. Okay? It can be used for any addressing sources, so you could either use for gazetteer or address space or any other sources that you have. And the file size is limited by more the machine that runs it. So if you've got a big chunky server with lots of memory and lots of CPU power, then you could possibly get FME to process that all in one big chunk. However, sometimes FME needs to be reduced down so it just processes in smaller chunks, so it's faster or a bit more robust. And then it's, how do we output that? Could we output that as a variance file, so you know that these are the top 10 matches, or this one is the most likely match, or just a corrected merged file where you find out which is the best and you're going to merge that and output it straight away, or produce a report to say we should replace it with this file. Okay, so the solution we're going to talk through is we're going to take a gazetteer, we're going to take some address space in our demonstration, or you could again take any other source that you wanted to. We could fix it for matching, so make sure that when we do try and match them, it's going to be as close as it possibly can be. We're going to actually do the match, and then again discuss how we could output that data. Okay, so here's the FME workspace. I'll work through it along the workspace, and then I'll zoom out so you can see other possible ways that we could do certain sections. So one thing to note right at the start is I've got our address space, the things that we want to merge onto at the start, and that'll become apparent a bit later on. So we've got our address space going in first, and as soon as that's read in, the gazetteer will move in and start reading those features. So the first thing that we do is we're going to copy some attributes. So we're going to open that up. For our address space, we're going to copy the attribute postcode and create a new one that's exactly the same, called no space postcode, which again I'll talk about a bit later on. And we do the same for the gazetteer, except we're also copying the first address string. So that's going to be things like flat C on the first floor, the middle of the building. And that has a lot of extra information that might not be in the address space extract. So we're going to use a string replacer to clean up and remove all of those phrases, those words. And we're going to replace them with nothing. So they're just completely removed. Okay? Thing after that, we want to remove any extra spaces. It's going to get every single word, every string, and just make sure it only has one space separating each one. So find every space and place it with just the one space. Okay, bit of regex. Then we're going to go to the attribute creator. This is still on our gazetteer, so our main source that we want to fix. And we're going to create different options. So we've got the first line of the address, but we've also got the second, the third, and the fourth line. And it might not match in that order. So we're creating 4 different outcomes, 4 different combinations. So the first, the second, the third, the fourth, the first, the second, the fourth, the third, and so on and so on. So we've got different combinations. And when we do our matching, we can see which one provides the best match. After that, we're going to go through all of those attributes again in yet another string replacer. Through all of these attributes, just our concatenated ones. And again, make sure there's not extra spaces. So we haven't got many spaces between each of the words. And then finally, an attribute trimmer, which is going to take the first and the last space from those attributes as well. So there's no starting or trailing spaces. After that, our address space comes into this string replacer, and our gazetteer comes into its own string replacer, which removes the spaces from the postcode. So again, it finds a space, replaces it with nothing. So that can ensure that our postcodes definitely match, because sometimes there might be double spaced or even triple spaced, or again, a start or a trailing space in that postcode. So eliminate all those variables, get rid of every space, so we definitely have a match. Okay, so here's our Python caller. This is where we're going to do our fuzzy matching. So I know a few of us might have used Python before, when some of us might have never seen it or wanted to use it before. But it's a fairly easy language. They teach a language in primary schools called Scratch, which is drag and drop blocks, so more like the transformers that we use. That, at the end, still in primary school, maps onto Python. So it's a very easy language to learn. So I'll quickly talk us through it. If you want to use external libraries, so the key library that we're going to use to do the matching for us is called difflib, and that's packaged with FME. So I can very simply just go import difflib, and it's available to me in this Python script. I'm going to use another one called UUID. Again, it's packaged with FME, so I just need to do import UUID. And if you want to use any other ones that don't come packaged with FME, then you just find it and you drop it into the install directory. And I'll show you that next time. And for now, in the Python script, in the init, that's when the transformer just starts, is initialized, set up. We're going to set a global variable, so one that I can access at any point during this script. It's called self, so it refers to itself, and I'm calling it AB features, so my address space features. And it's going to be a dictionary. Okay, so it's going to be a key and a value. In the input, so each feature will have to go through this section, this input section. I'm going to do an if statement. I'm going to get the FME feature type, which I exposed at the start. Okay, so there's an FME Python API, which lists all of these functions. So you can get any attribute, you can set any attribute, you can merge the attributes onto things, you can get the geometry. All of these things are available in the FME API, which you can see, but just by a quick Google. Okay, so I'm going to say, if the feature it has an FME feature type and it equals a CSV, I know it's come from my address space, because the feature type for my gazetteer will be gazetteer, will be something else. So I'm identifying just my address space. So then it falls into that. I do another if statement to get that no space postcode to see if it is in my dictionary yet. If it's not in my dictionary, then I fall in again and I create a list for that postcode. Once that's been created, or if it was already there, I'm going to get that key, so get that postcode, and store in the feature. So store in that address space feature. That way, when I search for a postcode, I'll have all of my address space features in one place, contained. So I can do my searches on a subset, so it's less memory intensive. So I'll end up, the key will be the postcode, and I'll have many features within that key, within that dictionary. And as I said at the beginning, address space is going first. So all of the address space features will come in and get stored in this dictionary. And then, once that's all been stored, it'll fall. Then first gazetteer feature to come through will fail this test because it's not of CSV, and it'll go into this section called constrings. And I'll make another small list of all my concatenated attributes. So every single one. I'll make a few more empty things. I'll use later on an empty list, an empty dictionary, and make a unique key, a unique identifier using that UUID library, which I'll use later on to merge together. So again, still in my gazetteer feature, I'm going to do a loop around to get all of the address space postcodes features from my big list of address space features. I want to get all the postcodes that match my gazetteer feature. And I'm going to store just the string, just the concatenated string from my address space feature into my secondary list. So I'm, instead of working on the big list of address space features every time, make a sublist just of the strings. It's very tiny memory usage. So once I've got, say, a small list of, say, 20 strings, those concatenated strings that I can match against, I'm going to fall into a try and accept. This is just a bit of error handling. It will try to do this block. And if it fails at any point, it will fall into this accept and give me an error. This will go straight onto the FME log. So if anything goes wrong, if I've maybe coded it incorrectly, I'll be able to see that when I run it in the FME log, and I'll be able to go to the exact line and see what the issue is. So inside this try and accept, I'm going to do a big loop around each of those concatenated strings. So I'm going to get the first one, which will be concatenated, and I'm going to get the result, which the result of my difflib library, which is the one doing all the work, to get the closest matches between that concatenated feature and all of the address strings which I stored. And I'm going to bring back the top 10. So once it's got the best top 10 results, I'm going to do another loop, because this result will be a list of top 10. So once I've got those 10, I'm going to loop around and do another function from the difflib called a sequence matcher, which will match each character and then give me a ratio of how well it matched. So I'll end up between 0 and 1, with how well that matched. So an exact match will be 1, a complete nothing match at all, 0. So I'm reducing the initial list down to 10, and then gives me an actual ratio of how well it matched. In this if statement, I'm saying if the highest ratio, so this dictionary I created at the top, if it's there, if anything's been put in there yet, then if it's empty, then move on so we can give it some information. Or if there's something already in there, I want to get what the highest ratio is already. So this is where you can go in two different directions. Here, we're just going to get the best possible match and merge them. But you could get the best top 10 matches, keep them in a list or a dictionary, and send them out one by one as different features. So then you can output that in your report. But here we're just going to get the best match and merge it together. So we're going to get the best, or what's there at the moment. If it's higher, if it's not higher than the new ratio, which we just calculated, then we'll skip on and we'll check the next result. But if it is higher, will fall in because it's a better match, so we want to keep that. So we have to do another loop, again, on our big list of features, address-based features, because before we only got the string. We only created a string here. So we need to get the main feature back. So we'll quickly loop through, and if it matches, if the concatenated string of the one we're using matches the one we're looping around, then fall in to our if statement. Otherwise, we need to keep going around until we can find that match. And because we want to replace, we're going to clear out that dictionary, so there's nothing in there. We're going to set an attribute of ratio, so the highest ratio that we have at the moment, store that, so we know it's either 0.6 of a match or 0.7 or so on. Set that feature, that attribute to that feature, and then in highest ratio, set the key as the ratio, so we know what can check in later on, and the value as our feature. And then once we've done all those loops, we'll continue out back into the main flow. We're going to set another attribute for address matching UID. So our gazetteer feature will have that attribute. If there's anything in highest ratio, which there should be, then we'll fall into this block. We'll output our feature. Then we're going to pull out the address-based feature, which is from our highest ratio. Set the attribute address match UID again, so that the address-based feature and the gazetteer feature have the exact same ID. So when we match later on, there'll be an exact match. And then we output that second. If for any reason there was an error or there was no matches at all, highest ratio will be empty. Or if you fall into this except, there'll be no setting of highest ratio. So we'll still output our gazetteer feature, and then we're going to create a completely blank FME feature. Set an attribute of ratio, where we say there was no match. There's no match in this feature, and then output that. Okay, and then it's finished. It'll move on to the next gazetteer feature and go through the whole process again. So once it's come out, we can go two ways. We could go up, and we can go into a test filter, where we say, if there's an attribute of ratio, then it's going to be address base. But if it's not there, if the attribute is empty, so it's not there, it's definitely going to be the gazetteer. So that's how we split it up, and you can go into a feature merger. But the problem with a feature merger is it'll have to store the features in memory to do the matching. So we've stored our address base in our Python caller over here, but it also means we'd have to store all of our gazetteers features and our address base features again before it'll match, because it'll check the gazetteer feature against all of the supplier, so all of the address base. But we know there's an exact match because we created that UID. So there is, you can do it this way, it's just a little bit wasteful, a little bit more time consuming. Another way, again, back into Python, is a little bit simpler this time. We're going to set up in our initialization 2 features for my gazetteer feature to be stored, my address base feature to be stored. In the input, I'm going to check if either of these are empty, so if it hasn't been set yet or only one's been set, fall in, check if there's an attribute of ratio, because only our address base feature will have ratio. Set address base feat to the feature that's just come through, and then it will check to see if both of them are filled. If both of them have a feature in, it will move on. Otherwise, it won't output any features at all. Okay. Otherwise, if there isn't an attribute of ratio, it'll go, it's got to be the gazetteer feature, so we'll just output that, or we'll store that away, sorry. So as soon as both of those features are filled, we can move into one if statement, else if, check our published parameter, which I've called priority, where we just give the user, do they want the address base attributes to have priority, or the gazetteer attributes to have priority? And by that I mean, if you're merging the gazetteer onto the address space feature, if there's any collisions, so if, say, postcode is exactly the same in both features, then the address space will take priority and it won't take the gazetteer, features attributes. It won't be copied over. Only the ones that don't appear will be merged over. So in this statement, I'm saying get the gazetteer features attributes and merge them onto the address space. If there's any collisions, the address space will take priority, and then we'll output that. If you wanted it the other way around, then get the address space feature and merge it onto the gazetteer feature and output that. And then, once we've done that, we need to clear out for the next two to come through. So a quick function, we say, get the gazetteer feature, set it to nothing, get the address space feature, set it to nothing. So when the next two come through, they'll be able to go into these attributes and be overwritten. Okay, so that's a quick feature-based merging compared to the feature mergers, transformers, group-based merging. So once we've done that, we're going to go to tester, again, check if there's a ratio. If there's a ratio and it equals no match, then go out to one report and show that there's no matches. If there was a match, go out to a different report and give me all the matches. So this is again how you could output to Excel spreadsheet to say these are all the matches or this is the best match, things like that. I'll show you over here a data inspector so you can see all of the features from the gazetteer are in, but then also all of my address space features have been merged on UID and that ratio attribute. So I know that these four have matched by 0.7 or 0.6, but I don't need to keep these attributes. I could do a an attribute remover just to get rid of any of the features, that I don't want, any of the attributes that I don't want, sorry. Okay, so back to PowerPoint. So a quick overview. We could use the Python libraries, Python callers. It's faster, there's less complication in the workspace, and it's fairly easy to learn. The cons of that, though, you need to be comfortable with coding in Python, and you need to have that problem-solving mindset just to get around the logic. You could do it in feature mergers. It's easy to understand because they're the big blocks and easy to follow. You just follow the lines, but it is slower. They're group-based and it's memory-intensive. Okay? In one of the other webinars, we'll show you how to use that, to use many feature mergers and the pitfalls you might find. Right? If you're coming from a database, you could run some queries. You could run, instead of going from flat files like we were, you could connect to a database and pull all the features in through there. Or even better, you could use the database to do the match for you. When you call it, get the database to do a fuzzy match on a string and then bring it through. Okay, and a very quick example of that is over here. You can pull in from a database, build up that string you want to compare to all the different attributes, copy the postcode and then back into the same flow, or from the gazetteer, build up an SQL string, so where the postcode equals the gazetteer's postcode, and then use a feature reader, where we connect to, in my instance, a Postgres database, and pass in that where clause that I just made. Okay. So once I've done that, again, pass it straight in. That way, I'm getting 10 address space features from the database. And then when that gets to the Python caller, I can use just those 10 straight away, instead of having to store all 90,000 of my extract. Okay. Another way of using this fuzzy matching, there is actually a custom transformer which we can all get called a fuzzy string comparer, which is made by someone from Safe, where a feature comes through and you can compare two attributes that feature has, and then give an attribute for it to store the ratio. It's using the exact same Python library in this custom transformer. You can bring it in and edit it yourself and have a look around and see how they built it. But in this situation, it doesn't quite work because you'll need to have merged together 10 different address space features to find out which one matches. So you can have a look around, see how it works, but in our case, it doesn't quite work that well. Okay. Key benefits. So as I said right at the beginning, you can get lots of different legacy systems, maybe older systems. FME's been around for a couple of decades now, so it will definitely be compatible with some of the older systems that you might have. Match the data simply and then send it back out to those systems, or have one key repository. Income generation has been improved. Your services will be improved as well, because everyone's working on one set of data that's been checked or merged, or it's all one section. And you don't have to spend money improving the data or like fixing the data. You just got one FME workspace to do that for you. Okay. And if you've got any external software or programs that is doing these services for you, then you don't need it. A little bit of investment in an FME workspace and you'll be able to not have to use those services or software again, because investment in FME workspace will be better in the long run. You control that. So in summary, address matching using FME to synchronize or update data sets that might be altered by the users, bring those changes in. Quality is improved. There's many solutions to the same end. So I quickly touched on others. We mainly went down a Python route, but you could go a feature merger route. You could start from a database. You could use feature reads to pull in small sections at a time, depending on what you've got, where you want to go, what reports you want to make, and what technology you've got, what you're using. Okay. Same method can be used, just doesn't have to be addressing, can be reports or general data that you've got sitting around hiding on your system somewhere. Okay, so thank you for listening. I know there's a lot of Python code that we had to talk through, but I hope you find that useful. If you have any questions, I see a couple of people around me have been typing away. So ask any questions below. I will be around for a half an hour to answer any questions that you have. And I'll try and answer as many as I can, or direct you to a place where you can answer them. Next week, we are talking about metadata harvester, searching your system for files that you don't know, giving you a report. Okay, so thank you for listening, and I'll see you next time. Thank you.